Hey guys, welcome to day one of online school. Today we're going to be talking about equation of a circle. So this is the first part of a two-part lesson, 8.1. Notice we're not talking about quadrilaterals anymore. We'll do that when we come back to actual in-person instruction. All right, so the warm-up, 2 points on the plane A equals 19,4 and B equals 19, -6 represent the endpoints of diameter of a circle. All right, and what we want to do here is we want to actually find the... Oh, there it goes. We got a circle there. We want to find the length of the radius of a circle. So in order to answer this question, what you need to understand is what is a diameter and what is a radius? Well, a circle has a center, right? And all points are equidistant from the center of the circle. Let me move that because that is not really popping. I'm going to put that center of the circle right in the middle. That's better. So we want to find the length of the radius. So the radius is the distance from the center of the circle to a point on the circle. So this is a radius. Right, so that's what we're trying to find. The endpoints that we are given are actually points that represent the diameter of the circle. So remember, the diameter goes across the whole circle, connecting 2 points that are actually on the circle. The diameter also goes through the center of the circle. So to determine the length of the radius, we're going to use the distance formula. And you guys should be fairly familiar with this. x2 minus x1 squared plus y2 minus y1 squared. All right, so pause this video right now, and I want you to use these 2 points to actually find the distance of the diameter. And we're going to use that to help us find the radius. So let's all get the correct distance of the diameter together. So pause the video and see how you do. All right, so we have that the distance, the diameter, is the square root of 100, which is 10 units. So that means my diameter is 10 units. And if you know anything about diameter and radius, you know that the radius is equal to 1/2 the diameter. So the radius is going to be equal to 1/2 times 10. So your radius is equal to 5 units. All right, so that's all terminology that you should remember from intermediate school, but we're going to be reviewing it throughout the lesson. So first, we're going to just set you up with some key definitions that you should be knowing. All right, so guided practice, we have a circle is a collection of points that are a fixed distance from the center of the circle, distance. All right, the radius is a line segment drawn from the center of the circle to any point on the circle. All right, so it is that distance from the center to a point that's on the circle. Now this one's tricky. I don't think you've heard of this one before. This one's called a chord. All right, now a chord is a line segment that has both of its endpoints on the circle. Both endpoints are on the circle. So here we have A and E. Endpoints are on the circle. The chord is the segment that connects those two together. And diameter is a chord that passes through the center of a circle. So it is a chord. So a diameter is technically a chord, but it passes through the center of a circle. Okay? All right. Exercise 1. Circles are often denoted by their center. In the following diagram, circle A is shown with points B, C, and D marked on the circle. A lists 3 segments that represent the radii of the circle. So we're listing segments. So you have to know proper notation for segments. All right? So 3 segments could be radii. So that means they have to start from the center and go to the edge of the circle. So AB would be one. AB. We're going to put that little line above it. What else? Could be a segment. Remember, it has to start at the center. It could be AC is another radii, right? Another radius. AC and AD from the center to the edge of the circle. Name the segments that represent the diameter of this circle. There's only one of them, all right, and it is diameter DC. It connects. It's a chord that connects 2 points on the circle, and it goes through the center of the circle. That's very important. So, for instance, this could not be a diameter because it does not go through the center of the circle. List all chords of the circle that are currently drawn. So, chords could be the diameter. Technically, diameter is a chord that goes through the circle. Also, dB is a diameter. A chord. dB is a chord because it just connects 2 endpoints on that circle. So we said DC technically, and dB is the real one. All right, next. It says, explain why triangle DAB must be isosceles. All right, so we want to explain why DAB must be isosceles. So we're talking about this triangle here, triangle DAB. Why must it be isosceles? Well, what do we know about isosceles triangles? We know there has to be 2 equal sides. Congruent, I tried to write, sides. So we said that DA and AB were both radiuses, right? So they're going to be congruent. So we can say 2 congruent legs since all radii are congruent. We have DA and AB are triangle DAB's 2 congruent legs. Why do we know that? They are both radii. They are both radii. All right, guys, so based on what you know about those definitions of segments within a circle, I want you to try this on your own. So pause the video. I want you to read these questions here and try to match the following with its correct name. All right, so the radii are which segments, diameter is which segment, and what's the chord that is not the diameter. So pause this video now, give it a try, and check to see what you got. All right, so based on the choices on this side right here, you should be able to identify that the radii were AO, OC, OB. The diameter was AB because it went through the center, and the chord that is not the diameter is PQ. It's a chord, but not a diameter. All right, last one for today. Connect B to C in the diagram shown, then classify triangle BOC as scalene, isosceles, or equilateral. Explain your answer. So it says, connect B to C. Connect B to C. All right. Is your triangle scalene, isosceles, or equilateral? All right. So this triangle right here, classify it. Pause the video now, classify it, and then press play to see if you were right. Okay. Triangle AOB, or what is it? COB is going to be isosceles because there are 2 congruent legs. All right, guys. So check back to the class page to see what your assignment is for quote unquote homework. I hope you have a great rest of the day. Stay healthy, stay safe, and you'll hear from me tomorrow. Take care.